Assalamu alaikum and good morning. Today I am presenting the presentation on industry automation with programmable logic control. And this is Mohammad Aifur Rahman, student of College of Engineering and Technology, and my bearing ID is 010505. And my program is Bachelor of Science in Electrical and Electronics Engineering. Objective. The aim of my presentation is that to show and focus my practical works into this presentation. Sequence. These are the sequence that this way I manage my presentation. First is about industry automation, and then PLC, programmable logic controller, advantage of programmable logic controller system, PLC used in Niagara Textile. Niagara Textile I do the internship. Typical work done by PLC in Niagara Textile Limited, PLC architecture, PLC system, input-output section, programming device connectivity. There is a practical example, recommendation and conclusion. About industry automation system. Industry automation system is the use of control system to reduce human work in the production of goods and service. Automatically, this automation system is a greatly decrease human need of work and as well as human sensory and mental requirement. Automation plays a highly increasing role in important role in world economy and daily experience. Types of industry automation. I found that 3 types of industry automation will be used. That is conventional automation system, PLC-based automation system, computer-based automation system. So in conventional automation system, there is only use some relay, switch, and do some simple works to do automatically. And PLC-based automation control system is a much more complex things we can add and we can automate using PLC programmable logic control system. And if we think about the cost, then we are used to computer-based automation system because computer-based automation system is less cost. PLC, programmable logic controller. A programmable logic controller is a specialized computer to control process and machines. PLC uses memory to store instructions and specific functions that includes on-off controlling, timing, counting, sequencing, arithmetic and logical operations, and data handling. This is the PLC used in Niagara Textile. Here, this PLC has this is the input module, output module, and analog output. This port are analog output, and this is the PCMCI card, generally called EPROM, and there is the tar port. This tar port is used to connect to PC for downloading program to PLC. And this is the auxiliary port, same ports. And here is the indicator. Different condition will show here. There is a battery indicator, run indicator, error indicator, input-output indicator. And here is the input power supply will be given. This PLC takes 24-volt DC to operate these internal circuits. And this is the name model of the PLC is TSX Micro 3722 PLC. This PLC used in Niagara Textile, and this invented by Modicon Electronics. And there is the battery. There is a battery. This battery is provide power to PCMCI card to store programs. This card is generally EPROM I mentioned. And if this battery is okay, the battery indicator will show the battery is okay. If we run the program, this indicator will show. And IO device is okay, connected properly into modules, then there is a signal showing. And if there is an internal processor problem, CPU problem, then there is an EO indicator will flashing, and there is some different level there is showing. Advantage of PLC control system. The PLC control system, why are you using PLC control system? There is a many of advantages, that is why we are using PLC control system. The PLC control system is a faster response time, flexible, less and simple wiring, solid state, no moving part. The PLC, if we put PLC in one position, we don't have to move the whole system. Modular design, easy to repair and expand. This basically this design is the quite nice and PLC used in Niagara Textile. Those two models I saw in Niagara Textile, they used PLC, PSX Micro C722 and Plausible T160. Typical work done by PLC in Niagara Textile. Those works are done in Niagara Textile: speed control of induction motor, water level control, different type of temperature control, control of finished machines, and control of shift counter, identification of safety work, emergency alarm system. This is the PLC architecture. This program, 4 parts here: program, memory, input output, and central processing unit. Those memory, central processing unit, and input output are internally connected by address, data, and control bus. So memory directly, if an input output device is connected to real world. What is the real world? Real world is that real devices are connected here, like sensors, HMI devices, and some speed detectors. And this type of device are connected here. And central processing unit processes the input from input devices, and memory is to store the program to the control whole system. And when comes from any signal to input, central processing unit processes the whole signal and then send to output devices. PLC system. This is the PLC system. Here is the module, input module, and input module is connected to input sensing devices. This is central processing unit, CPU, and memory, program, and data. This is programming device, and this is output module. Output module is connected to output devices. So power supply are connected to central processing unit, module, input module, and output module. This is the small PLC system. In the larger PLC system, this power supply will be different from different type of input module. So power supply will be section will be different. And this is small, so that is why power supply is same for those CPU and modules. The processor. The most important part of the PLC is the processor. Processor is like a brain of PLC, and it is doing the processing the whole input signals and send to output devices, and executed programs. The processor accepts input data from various sensing device and processing those data and send to output, sends the actual result into output devices. This is the input now. This is input output section. IO section consists of input module and output module. This is the IO section. This power supply is connected to IO section. Input module. The input module consists of input module is interfaced with directly with input devices and control the sends control signal to the input, receive signals from input devices and to processor. Input module are the middle of between processor and input devices, real devices. This is the output module. Output module is the interface with output devices, and this is also like that the middle of processor and output devices. This is the power supply. We will supply DC power into the PLC to processor in modules. And I use the TSX Micro 3722 PLC. This PLC takes 24 volt DC power from this power supply. Programming device. So programming device is a device to program into PLC. Programming device is like a personal computer. If we can use personal computer as a programming device, we have to just take software, install a software, and making software. So before we do programming, we need to have some software. So this software I listed, I worked the software. For PLC programming, we need PS7 4.4 and Win Pro Ladder. So PS7 4.4 software is used for PS6 Micro 3722 PLC for programming purpose. And WinPro Radar is used to Siemens Siemens PLC. Those we can program into WinPro Radar. So different type of PLC we need to different type of program. The manufacturer or provide programs we could easily program, and there will be manual for programming purpose. And for HMI device design, we have to read VGO design 1.1. And this is the basic device connectivity. Laptop are connected to PLC, and PLC is connected to inverter. Inverter is connected to motor. To like imagine that for speed control. And this is the PLC connectivity. This PLC TS657 or TS636, two type of PLC here connected to PC for serial link connector, and here is the connected cable TS6 PC 1030 cable. These cables are generally used for PC PLC connection, RS232 cable and PS2 USB cable. This cable is when we downloading the program PC to PLC, then we have to need those cable to transmit the program into PLC. This is sensor connection. Here you can see the hydrostatic sensor and water level sensor. These sensors are directly connected to input module. To the sensor sending different type of signals. The signal range is 4 milliampere to 20 milliampere, and sending different condition of water level. There is the vat. This vat is water. This sensor is sensing the different conditions of the water and send the signal to PLC. The wire connectivity with PLC. Here is the input device are connected from the wire, and here is the output device going. This wire is going to output device, and this wire is coming from input devices. And here is the HMI device, human machine interface connection. This is the human machine interface, HMI device, generally called HMI devices. This HMI device is used to manually control PLC. Sometimes we need to manually control the motor. So if we use HMI device, this is a touch screen. We can easily control the motors or sensing device from here. And monitor different type of device activity. If there is a device problem occurs, then here is showing what device are problem and statistics, what level is going on. Different type of level are showing here. And now I will discuss about practical example in what I done in internship period. This is the mixture process control problem. Here is the process pad and motor. This is the motor and water is coming. And this is the pressure sensor switch, temperature sensor switch, and manual input button. So in a dyeing machine, I saw that there is need to mixturing some colors with water. Define all time if this is the motor, and different type every time we need not to control rotate the motors. So sometimes we need to rotate the motor, and we have to do these things into automatically by PLC. So this sensor, when desired pressure and desired temperature will reach, the motor will be rotated. So I explain this thing in the PLC program. So there is the problem I showed, and when temperature and sensor switch are close their specific contact, then condition will fulfill. And manual input button is also provided for manually start the motor. Here is the process control relay ladder logic. So here is the process pressure switch, and here is the temperature switch, and motor starter coil, manual input button. So in here, if pressure switch is closed, temperature switch is closed, then motor coil is energized, and then motor will start rotating. And also, we can another way, manually push button. If we close manually push the switch, then all those two switches are also closed. Then motor starter coil is energized, motor will start rotating. So here is the thing. Logic is that pressure switch. If we value set on pressure switch the 5 kPa and temperature is 10 degrees Celsius temperature. If 5 kPa occurs, then pressure switch is closed, and temperature 10 degrees comes, then temperature switch is closed. Then this condition, when this condition is fulfilled, those two switches are closed. Motor starter coil is energized, and then start the motor. And mixture process is going on. And there is the PLC input module connection. And above diagram, we can input module connection this way. The same input field device are used. Those devices are wired to input module according to the manufacturer labeling. So for manufacturer labeling, we can input connecting input devices. Here is the 1, 2, 3, 4 is the port for connection input devices. Pressure switch is connected to 1, and then temperature switch, manual input button. L1, L2 is the coil winding connected here, and 120 volt AC. Here is the PLC output module connectivity. One is going to the motor starter coil. This coil, if energized, then motor will start running. And there is a PLC ladder logic program. So in ladder logic program, we can do the I1, I2, O1, and I3. Those are I1 is the input devices, and O is the output devices. So I1 is pressure switch, temperature switch is I2, and manual input button is I3. So here is the 3 input and 1 output. This is the motor starter coil. So entering and running the program. When we design or make a program into ladder program, we have to download this program into PLC by using a cable or cable as a medium. And then when download is complete, downloading this program button is pressed, then we can download the program PC to PLC. And here is the run button. If we press the run, then this ladder logic program will run inside of PLC. PLC operation cycle. The PLC operation cycle is mostly important. So here is the operation cycle. Mainly what done processing is that, and this yellow portion is showing that the IO scan. If IO scan is less, then PLC efficiency will be increased, high. So IO scan time, if we decrease, then PLC efficiency will be increased. Here, personal computer-based control system. We can use personal computer as a control system. So this is the advantage if we use personal computer as a control system. Lower initial cost and less hardware and software required. Straightforward data exchange with other systems. Speedy information processing. Easy customization. So while I'm doing work, I feel some things that will I recommend here. So need skilled person in this automation field, because whenever I got some problems, I couldn't find any special person to discuss about those problems. But sometimes I got the solution, but maximum time I couldn't find the problems, so we have to go internet and finding solution. And need extra course in study level. So in our course category, there is nothing about automation system. So we have to manage and manipulate a coursework to do to know in automation field. Make some part of automation system oily. Or every part is not we can automate. Every part of automation system we couldn't do wirelessly because there is a input power problem. So some part we could do automate and we can decrease the cable complexity. Well, this is the big sector and we have to take it seriously and need more opportunity for practical works because one PLC is price is so high. So that is why if we are going to industry, if I could do a practical works, but PLC is unavailable. So how could I do practical works? So this is the problem, and we have to need more practical opportunity for this work. And this is my conclusion. In my total internship year, I learned lots of things in industry automation, and I tried those things. I tried to focus those things into my presentation, and mostly I focus about industry automation, programmable logic controller, device connectivity, sensor connection, human machine interface connection. And most time while doing an internship, I just saw device connectivity and how to control the device. And PLC is so much important device in industrial automation sector, and PLC doing many types of automation tasks in industrial field. So that's all my presentation. Any questions?
It's more comfortable with automation systems cheaper than PLC-based automation systems. So why engineers should
because of efficiency. So if we use personal computer-based automation system, then efficiency will be less because of there is a problem of virus problem and operating system problem. Mainly is the operating system problem, and some operating system is the real-time operating system is called. So this real-time operating system will do the real-time working while input are coming and then go to output. The slow response time. So that is why there is also problem is arise because the operating system is big and we have to connect it cable into the complex manner will be increased. So that is why efficiency will be increased. So I personally recommend that for this, right? The PLC will be the better for this automation. But if we have the costing problem, then we can use personal computer as a automating it. Because one PLC is the costing maybe 2 lakhs, 3 lakhs, and if we use personal computer, then 30,000 will be, and something like we have to spend in input devices connectivity. So maybe 40 or 50,000 we could do a whole automation system using PC base.
Another question is, do you use a program or logic controller? Did you use any program? Can you do any program?
Yes, this program in practical example section.
It's two program you use, right?
Yes.
Name of the program.
Name of the program. Ladder logic program.
Slide number 9. Slide number 9.
And which language you use?
I use TSX Micro 3720 PLC. This PLC is programming purpose. This PLC is using the software PL7, and this PL7 is provide 3 types of programming languages. Those are instruction-based language, ladder language, and FBT, that is flowchart-based language. So I use ladder language as a for programming purpose because I have much interested into other programming languages, but I didn't find any suitable person to know the ladder language, another logic. So I found so that is why I know something about ladder logic.
Can you?
Yes.
Why you didn't show here?
Here is the ladder logic program in practical example section. This is the BSc ladder logic program.
Block diagram. What is the program?
No, this is not a word diagram. This is how it's programming. This symbol will into the programming software, and we have to click those symbols and put it into the script, and then this is why ladder logic programming will be done. This is the program. This is not a conventional C programming. We have to, if this input is happen, then do output. This is the ladder logic program this way. And going to
have this program in your laptop?
right now I can bring my laptop, but if you want to know, I will provide my web address. You can see here. See there.
Do you have personal website?
Yes, I have personal website. These things are my board reports and presentation is also I uploaded for knowing to other person to sending the information.
But just placing the figures, you can write the program, you need to set some parameters here also?
No, we didn't need to set any parameters because
Must set the pressure switch. How much
But in
pressure?
the report there are some programs also.
pressure switch, there is the pressure sensor switch, and manually we put the pressure about 5 kP.
Then where is where you will set this 5?
No, there is not need to set here for 5 kP.
Then what-
Pressure switch is available there in here. Here, pressure sensor switch. This sensor has the preset value. What we need to know. This sensor we just put 5 kPa as a preset value for pressure sensor. When 5 kPa is occurred, this device is transmit a signal.
But if you need to change this 5 kPa to 5.5 kPa, then what will you do?
We can manually change here. Because automation, if we done the automation, there's all things we cannot change, because firstly when we done, then this is the customization.
The
We change.
stage where you will not get that is operation level. But where you will make some programming, then you need to change set some parameters.
Yes.
Operation level.
Yeah, when we need to change this level, so this is the customization of program. So with customization of devices. So if we customize the device and this device, the temperature will 10 degree. The preset value, if we set here and here, so this preset value will work in this process. But if we change like 5.5 pressure kPa, then we have to customize all the systems. So how we customize the preset value? Here we can change the temperature sensor. Here we can change
The operation level.
in the operation level.
It doesn't mean you did the program, you just operate.
No, my supervisor instructor will show how we could do the ladder logic program, and he firstly shows this way we could program, and this program we can run this way, and I just practicing from this because I am the new in university course I didn't find any automation or any ladder logic program. So totally I am the new person of automation.
That program you did in the computer,
Yes.
not directly on the PLC. You did in the computer, and if it is needed in the PLC, you download from the computer.
Yes. Firstly, I install a software in PS7, and this software I do a program, make a program, and PLC is connected to computer laptop. Here is a picture also. Here is a picture. This laptop, there is a PS7 program is there, and then connected to this is the PSX micro PS722. This used to NAG textile, and this start port is connected to the USB port. This is the PS2 to USB cable we are using for downloading program keys from PC to PLC. And there is the run button here, and if you run the button, then automation process is going.
So,
And I just use
what
this
you have done your internship?
in Niagara Textile Limited.
So, okay, can you show us any teacher that you go to Niagara Textile?
This is picture I take from Niagara Textile workshop.
If I say that you take this lecture where you complete your PLC training program.
PLC training program.
Yeah, this type of commercial training is available. You use some you use one picture and come up with it. But how can you prove that this picture is from diagram?
Because I personally I didn't think that if I provide I have to prove to IUBAT
Any picture, any evidence?
No, I personally I don't take any pictures. This I available there. This is Niagara textile. I don't think that this is the way to.
So, they are using this PLC computer. So in various sections. So why is that? Why you take this picture from workshop? Why you want to take from the practical application and thereby in the site?
Real place.
Yeah.
While I'm doing automation, I just all time I saw the connectivity problems, and in that time I didn't take any pictures. I didn't have any cameras, so that is why I can't take the pictures, real picture. But
If I say that you give this whole presentation from a section of speed control of three-phase induction motor by AC inverter.
Speed control. Sorry, I didn't get it.
It clearly written. This report from speed control of three-phase induction motor by AC inverter.
No, sir, this is not my.
This is your report.
If there is my name, then it will be my report.
And if no name not present, it is not here.
So if I
don't have to read this line and read the other line. Okay?
sorry, sir, maybe this is my typing mistake. Typing mistake. Yeah. Printing mistake, sir.
Printing. The printer inserts some elements in it. Itself composed for you.
Yeah, this is comfort for me, but I didn't.
Who composed for you?
Yes, sir. Extremely sorry for this, sir.
Because you copy. Why?
Mr. Arifur Rahman, do you have any intention for further studies?
Yeah, I want to do further studies for after finishing my graduation in here. Then I will do MSc engineering.
So where is that? You want to do it in Bangladesh or outside?
Personally, I think that I try too hard to go in abroad, but if there is not possible, then I will do MSc from Bangladesh. So there is a university. First, I try to wait for admission.
So far, what I have seen, you have a very kind of crystal clear concept. I'm very happy about it. About the confidence you have, and other thing, I'm amazed. But the one thing just you need to look for probably is just concentrate a bit on your English.
Yes.
Just a bit. Otherwise, you're a complete package.
Yes.
This is slide number 3.
Yes, sequence.
Please read the line number 5.
Typical work done by PSC Niagara Textile Limited. Typical work done by PSC Niagara Textile Limited.
D-O-N, is it done?
Done. Sorry, pronunciation mistakes.
Proceed your recommendation. Recommendation.
Here. Yes.
Your third part. Make some part of automation system wireless. What do you mean by this?
Because some part of the PLC or automation,
Name it.
yeah,
Name the parts.
the connectivity between sensor to PLC. This connectivity we can use wirelessly. We can. using Bluetooth as a device for.
How?
If we add a Bluetooth device into input sensor and PLC there is a Bluetooth control, then these are those connectivity we could do wirelessly, and some output device also we could do wirelessly.
That means you're saying that your PLC has a inbuilt Bluetooth sensor.
No. I
Then
just personally recommend that.
in that case, you're modifying the PLC, right?
Not modifying the PLC. I just suggest that these are possible to do wirelessly. So.
But your solution is not clear to me, so make it clear.
Yes. While I am doing works, I saw there is a many cable complexity. So these cables are going to input devices, coming from input devices, going to output devices. If we could do this system wirelessly using Bluetooth system as a system, so there is cable complexity is less. Because I am doing.
But do you have any idea whether really it will work or not? Do you have any concept?
I have concept. I didn't really show, really seen this type of things, but I do some research into internet and then I realized that it is possible to use wireless some devices. So that is why I recommended that if they.
Okay, that is why I am asking you.
Yeah.
If it is possible, in that case, give an explanation on that it is possible in this way. First thing is, your PLC is a complete product, isn't it? You are buying it, you are not the manufacturer. So you cannot make any type of, any type of modification in your product. As it is not your product, and you are not the manufacturer, right? So either if any PLC is available with a Bluetooth sensor, you will have to purchase that. In that case, you will have to get rid of your present PLCs, right? So how you will be able to use your present PLCs in this concept?
Okay, I will explain for one picture. Something like that. There is a cable complexity. Many cables are connected, and this is the original PLC provided by manufacturer. Okay, I have not changed this product. Just add another device to this portion. If we add this Bluetooth device into this portion, the Bluetooth device is transmitted without the cable to the input devices.
What type of Bluetooth device?
Bluetooth device is a.
What type?
Bluetooth device.
Why?
For decreasing cable in complexity.
Is your PLC has that option to adopt a new Bluetooth device?
Yes, many of PLC provide the connectivity.
This one, I'm talking about this one.
This one I didn't know. That is why I recommended.
When you're recommending something, you
So what is the problem with this existing system?
This is the problem. I think that the cable complexity.
You may think many.
But you can't recommend anything in the report if you do not have any clear concept that I can do it. Yes, maybe you can interface your Bluetooth system with the PLC, but the PLC has to have that option. Okay. Now you do not know whether your PLC, this one, as you are working with it and you are recommending on this PLC, and you do not know whether it has that option or not to adopt that Bluetooth. You do not have any concept whether it can adopt that Bluetooth device, whatever you are thinking or not, right? So how you are recommending it? Because you are depending on this PLC, not others, not other PLCs. Okay, you have worked with this, and your recommendation should be based on these. In that case, you will have to give a clear idea whether this PLC has that option to adopt Bluetooth technology or not. If it has, in that case, you will have to also give a brief suggestion how you can adopt this Bluetooth. or this interface the Bluetooth with this PLC. Is it clear?
Yes. I want to say something for you.
Yes, please.
Okay, we are running out of time. Let's say you're concluding.
Thanks, honorable teacher and course coordinator, to give me a chance to show my practical work for using these presentations. And thanks all.
Now, next participant is Suredas Min Dehenua. He has completed his internship at Robi XCR